The BritChips Podcast is proudly sponsored by Silicon Catalyst UK. Hello, I'm Anthony Miller, and welcome to the BritChips Podcast, where I have conversations with movers and shakers in the UK semiconductor startup scene. Now, here's a fun fact. Heron of Alexandria was a Greek mathematician and engineer who was active in Egypt during Roman times. According to his biography, Heron invented many machines, including a steam turbine, but his best-known mathematical work is the formula for the area of a triangle in terms of the lengths of its sides. Now, I tell you this because my guest today named his company in honour of Heron of Alexandria. He is Alexander Montgomerie-Corcoran, CEO and co-founder of London-based semiconductor startup Heronic Technologies. Alex, welcome to the BritChips Podcast.
Brilliant. Well, thank you for having me.
It's an absolute pleasure. Now, Alex, I do know that Heronic has nothing to do with steam turbines or triangles for that matter. So perhaps you could start by telling our audience what Heronic is actually developing.
Well, at Heronic Technologies, we're automating the design of bespoke AI hardware. So what does that actually mean? We're taking specific applications, such as, for example, at the moment, we're working on super resolution, or say if you want to do object detection. And instead of this one-size-fits-all approach that most semiconductor chip makers are going with, the likes of NVIDIA, AMD, we're making chips specialized to specific tasks. And so that affords you a lot greater efficiency, a lot lower latency, and really delivers on this performance per dollar metric.
Okay, well, I would like to go into that, and particularly from the sort of the customer journey point of view in a second. But let's go back in time. Let's go back to the beginning of your journey, because if I understand correctly, Heronic was not your first startup. That was a business. It seemed to be called Collabo, I don't know, back in 2018. I mean, what was that all about?
Yeah, so I guess that's where my entrepreneurial spirit started. Let's put it that way. During my undergrad course, I met a friend who was into music. I'm a musician myself, and he wanted to find ways of collaborating with, meeting different musicians, collaborating with different artists. And we sort of came together and created this app. As an app at the time to link up musicians. But I mean, it was really fun. The whole process of starting a business is very boots on the ground. We were running events to, get more musicians involved. We were doing all these promo videos. I mean, retrospectively, it wasn't the best idea, but it's good experience nonetheless.
But it sounds like you enjoyed it. I mean, did it just sort of run its natural course, or just ran out of cash?
It was more, we realized it isn't what we want to dedicate our lives to. And I think especially going to Imperial, one of these top universities, because we want to specialize, we want to gain this experience in really deep technologies. And we may as well utilize that. We may as well do something useful with the knowledge that we gain from there. So that's more the reason why we let that go. It didn't feel like it was meant to be our life's work.
Now, when you said we, is this Petros you're talking about?
For Collabo, that was someone else.
Well, that was someone else. Okay, because Heronic's journey, if I understand correctly, did start at Imperial College, London. And that's where you met Petros, wasn't it? How did all that sort of come about?
We were both researching this area of accelerating AI algorithms on FPGA devices.
Are you doing that independent? You were researching that independently of each other?
At that point, yes. So also, maybe I can just tag on FPGAs. That stands for Field Programmable Gate Arrays. It's this configurable hardware which affords you the opportunity to play around a lot with what you're doing on the hardware side.
So they are basically, that's what it says on the tin, field programmable, as in they're programmable by the customer after the chip has actually been manufactured. And depending on what they want to do with it, they just program it and it does whatever they want within the capabilities of the chip.
Exactly. It's more for these kind of lower volume specialized use cases where you need custom hardware, but you can't afford to go through the whole tape out process and the time to market and everything. So it's great for research. You get to play around with, state of the art. You can create really specialized solutions and not have to wait for something to come back within the next 12 months. So it allows the papers to leave the door a lot faster.
Yeah, and doesn't cost nearly as much as doing a proper piece of silicon.
100%. Yeah.
So what point did you and Petros then kind of realize you were following the same ideas and decided, well, let's do it together, chaps?
Yeah, I mean, yeah. So going back a bit. So yeah, we were sort of researching independently different ways or different flavors of accelerating AI on FPGAs. Myself, initially, I was focused on low power design methods, ways to incorporate into the architecture lower power features. Petros, he was looking more on the application sides, with 3D networks, sort of action recognition, and depth-based workloads. And yeah, we were sort of going in our own separate areas. I was getting state-of-the-art results for low power, but I wasn't able to really utilize that with his 3D networks. And so we kind of came together to find a way of compounding the benefits of each of our research directions. So, and also being lazy PhD students, we wanted to automate this process as well. So, I mean, the company really started when we were working on this research tool to allow us to incorporate different aspects of our works together.
Now, you were almost dismissive of what I think is probably one of the key, USPs of Heronic, which is this like design space tool that you and Petros have developed. Can you just talk a little bit of what that does and how that fits into sort of the Heronic business model, if you like?
Yeah, I mean, designing chips are hard and it's a long process. So ideally, you don't want to start from scratch every time. What we've created is this way to go from a specification down to a RTL description. So describing how to implement an AI accelerator architecture. And so what that involves is, okay, it's first mapping operations in the software space to a hardware implementation of it. And then that's kind of the starting point of this is a bare bones implementation of how an AI accelerator would work, but it's not necessarily reaching the performance constraints it's not reaching the performance that you want within the constraints that you have. So say if you're optimizing specifically for low latency, you need to assign more resources and reduce the pipeline depth to get the latency you want, essentially. But yeah, basically it's a very large, very complicated design space, which manually searching is almost impossible. I mean, we did a bit of research into that. There's billions, if not trillions, of design points, even for a very simple AI model.
Yeah.
So imagine if you were the engineer tasked to find the best solution, it would be impossible.
But you've designed a tool then where you can put in the specifications, the constraints within which both the device works and what your customer is looking for, and it will select the appropriate model or the architecture. What is it actually pulling out for you?
Yeah. So the inputs to our tool are, first of all, the application. So this is the AI model or a set of AI models. It's what you want to run on your dedicated piece of hardware in your system.
Right.
There's the technology that you're deploying onto. So that's either a specific process node or an FPGA device as well.
And
So that's
initially you're working on FPGA devices. That's your sort of entry into the market, so to speak.
yeah, that's our go-to-market platform. Because we don't see any reason not to do that, right? Where our value add is on the architecture itself. So if we can design for FPGAs and customers can start using our hardware, our technology immediately, why not?
Absolutely. Well, let's talk about customers and how the process works, because I understand you're working closely with Altera and their FPGAs. I mean, there's lots of FPGA manufacturers out there. Actually, just out of curiosity, why are you working initially specifically with Altera?
Yeah, I think it's a great point in their journey and our journey, basically. So of the larger FPGA manufacturers, there's basically AMD, Altera, then Lattice, and there's a few more, smaller device companies, Affinix, Goin, Acronics. Yeah, so from Altera's side, they have this new lease on life. So last year they spun out of Intel and they came out with this direction specifically around AI. So they want to be the leading FPGA provider for AI solutions, and we want to be the leading AI architecture provider. So it's kind of, it's a perfect fit. They're providing the perfect platform for deploying AI, and we're providing the perfect IP for accelerating those kinds of applications.
Because when I was thinking about it in terms of customer relationship, there is, as someone once said, there's three people in this relationship, isn't there? There's Heronic, there's Altera, and there's the customer. And can you just help us understand how how you work with the customer and find your customers, or does Altera introduce them to you? How does that sales process and business process begin?
Yeah, I mean, looking at everyone's motivations, Altera's main motivation is to sell as many devices as possible.
Oh, yes.
Their customers know how they want to use these devices, but they might not necessarily have the IP. They might not necessarily have the design team internally to make that happen. So their end customers are the ones looking for IP to use in conjunction with the device.
To accelerate the device, because what they're saying, what I think you're implying is they see that the Altera FPGA is fit for the functional purpose, but may not meet their performance requirements or latency requirements or some special requirements for their application, and they need IP to make that happen.
But yeah, it's more like the device is a blank slate that you can use for whatever purpose. The customer knows how they want to use this device. Altera is good at advertising why their device has better properties than their competitors. At the end of the day, those properties don't matter if you can't actually use them, right? So that's where we're adding value. We're giving customers an IP. We're giving them the design to allow them to, or in this case, accelerate AI, but overall help them build the system they want to build.
Okay, so is it Altera then that comes to you and says, "Look, I've got a customer here with wants to do this app and these sorts of requirements," and they introduce you, and then you work with the customer to sort of design what it is they want?
Yeah, so that's a relationship we have at the moment. So they get inbound customer requests. They know what their customers are using their devices for, and they're sharing some of these insights. So we know where our IP will actually be useful. But not only that, we are also going out there and finding our own customers. So I mean, we've been to last year at a few trade shows. It was most notably IBC. It's a international broadcast conference where there's a lot of FPGA devices and there's a lot of potential for AI acceleration, but currently no one can actually deliver in that market. So we have this real opportunity to create a new space for AI acceleration.
So it's broadcast and all that related technology. That's your sort of beachhead market for your technology.
Yeah, so we've identified broadcast and Pro AV. So this is essentially video processing pipelines. We've identified that as our beachhead. Um, it's a space where there's this very high performance demand. I mean, everyone now has, or maybe not everyone, but a lot of people have 4K TVs. They want as high quality video streams as possible, and that's coming all the way from the camera that's recording the content, all the way down to it being broadcast onto your screen. And likewise, there's a lot of other applications of video processing and Pro AV. So another example would be video walls. So these are large scale arrays of screens of panels that, I mean, you can imagine somewhere like Piccadilly Circus, for instance. So those screens there, it's a massive array, a massive resolution that you need to drive with. Say if you want to drive it with a YouTube video, it's going to look terrible, right? So you need, ways of increasing the quality of video to meet what customers expect from these.
So your designs are more about the display rather than the capture, or do you have chips and designs suitable for the cameras themselves to capture the images, as well as chip designs which will do the sort of upscaling of HD to 4K to who knows to 8K? Where are you playing in this market?
Yeah, it's more so on the video processing side. So upscaling, that's actually our first product, is an AI-based upscaler. So it's taking very low resolution video feeds, 540p,
Wow.
something that's
Yeah,
tiny, the size of a postcard on most TV screens,
yeah,
and upscaling it all the way to 4K.
and
So
having a
it's this,
spectacular picture, getting a spectacular picture out of it, I assume.
yes, of course, of course.
Now, let's use that example. So, a customer comes along, whether they're introduced by Altera, whether you found them with this application. In fact, they've said, we're going to be using this particular Altera FPGA. Will they have done some initial design of the app itself? I said, this is, we've designed this for video processing. What we need now is to make it go faster. Alex, can you help us make it go faster? I know it sounds a bit simplified, but is that kind of how it works?
For the most part, yeah, it's not always the same. So it's not always that case. There is especially in especially in broadcast and Pro AV, there is a lot of wiggle room, so to speak, when it comes to the application. So, I mean, upscaling, for instance, a lot of the customers, they don't necessarily care how you're doing it, just they want higher quality video processing. And so we have a bit more freedom to play around with what the model looks like, with what the application looks like. But then there are some customers who've come with this specific model that they've tested on their side, that they know that looks good. Yeah, then it's more of this, straightforward pipeline of going from the application down to the design.
So, and it's the design which is the first step in your process. So wherever the customer is in their process, when they engage you, you are a design house for at least designing the AI architecture that goes on the chip. Or do you go even further than that and help with the design of the actual application functions as well?
I mean, in video processing, it's pretty straightforward how things connect together, how systems get integrated. So it's often this pipeline of, one filter, one processing node into another, and then instead of a traditional upscaler, we're almost swapping out one for one with our one instead. So it's just this drop-in replacement, essentially.
And which part of this is sort of unique IP? Because you're not designing new machine learning models, language models, are you? You're trying to select the correct model, the sort of architecture that can be used in that particular case?
Well, where our unique aspect is the accelerator architecture. So it's the way of executing, the way of running the AI model. We've designed, I mean, our style of architecture is this streaming approach. So instead of the kind of, you call it systolic array, this like monolithic architecture where you're mapping any operation to essentially a matrix multiplication, we're implementing pretty much one-to-one how the operation on the software side is described in hardware. So there's none of this, there's no off-chip memory overhead, which is a massive bottleneck for a lot of other accelerators. We're doing all of this in the chip itself. The data flow is one operation straight to the other. Yeah, we've removed one of the biggest bottlenecks in AI processing, which is this off-chip memory. So that affords us, all the efficiency gains that come along with that, using the arithmetic, basically the compute to almost 100%, as really utilizing what the hardware has on offer.
You're driving the chip to almost its maximum capacity, maximum utilization. That's what you're able to do. What's the situation now with customers and pilots and the like?
Yeah, so we concluded our first pilot, so to speak, with Altera. So they have a new range of FPGA devices that they want to show off, and there's this common benchmark, ResNet 50, which is it's a kind of go-to when you're comparing. It's an easy way of comparing apples to apples, different accelerators, different AI chips. And so we did a design for them so that they could go off and market their new chip for AI. With that design, we showed not only 2 times better performance over NVIDIA Edge GPUs, but the real killer aspect was this 30 times better utilization. So it's, we're really pushing the boat out when it comes to how much we can use the compute available on these chips.
Have they sold any of these new chips yet?
You have to talk to them.
Well, actually, what's the commercial arrangement then between you, Altera, and the customer? Obviously, I don't expect you to disclose confidences, but in outline, if, let's say Altera has introduced the customer to you and you've taken on the brief, you've got this design work to do. Do you have some sort of initial sort of consulting contract with the customer to do the design work?
So the first stage is an evaluation license that enables them to see what it looks like in a sort of demo system, and they can, verify on their end what the performance is and, whether it's meeting their expectations. And so once that's gone through, then we convert that to a full license. That's an upfront fee, and then once they start shipping units, it's a per unit royalties.
Right. Okay. So you get the benefit of that as well. Well, once that work is done, then from then on, it's really a royalty-based system. You don't have to. Go back and do any redesign, do you?
No, we have there's a maintenance aspect to it. So there is a yearly maintenance fee, and that supports any relatively minor changes, any updates that they have in their system that they need something changed on our end.
Or just in case there might be the odd bug in there. I mean, who knows?
No chance.
Never happens. Never.
That never happens. No. Exactly. Yeah.
May I ask, are you actually generating revenue yet?
We do have a bit of revenue, so right. We are generating some revenue.
Okay, but because that comes back to one of the key issues that all startups have, which is how do you fund all this development? How did you start with the funding? How did you get funding? Where did you get the funding from to get you to where you are today?
Yeah, so I mean, we started just bootstrapping. Like it started out as a bootstrap company. We had a lot that we could bring over from our research. So in terms of from the product side, from the technology and the product side, we weren't starting from scratch.
Right.
Let's put it that way. So that meant that over the first 6 months to a year of the company, we weren't like bringing together a lot of development. We didn't need to grow a massive development team. We could actually start working on. We had the capacity to start working on customer projects almost immediately.
I mean, how many people were
essentially what we did?
Sorry, how many people were in the team at that stage?
It was just two of us.
Okay, you and Petros.
Yeah, me and Petros. Yeah. So we and we got our first contract within the first 6 months of starting the business.
Wow.
Yeah. So we got going quickly.
Say who? Are you able to say who that was with?
That was with Altera.
Oh, that was with Altera. Okay.
Yeah, and then since then we've been able to grow the team. So we brought on our first employee, who started in June of last year. And yeah, we've also been fortunate enough to receive grant funding. So we've been awarded an Innovate UK grant starting in September last year, and we're currently raising. So we're raising a pre-seed round at the moment. The target's 1 million. We already have half of it committed. So we're just trying to close out the rest.
Where are you looking for that funding? What sort of people or organizations are you approaching? Because one of the observations I make, having spoken to many, many semiconductor deep tech founders, is it's tough to find traditional VCs here in the UK who understand the tech, let alone are willing to put their money behind it. Where are you going to?
Yeah, I mean, partly angels. We're fairly well connected through ChipStart and also through our own network with angels around the UK and abroad. There are VCs who are, I mean, it's a hot area at the moment, AI semiconductors.
Yeah.
So there are a lot of VCs who are interested. Whether they're actually putting their money where their mouth is another story. But yeah, the other aspect is, I mean, semiconductors is such a global industry, and we don't want to constrain ourselves to just the UK, and that's both with in terms of the market, but also investment as well. We actually see a massive growth area in Japan. That's a large market for us from the go-to-market side. That's a large market for FPGAs, and so we actually secured investment from a Japanese VC. Wow.
Just out of curiosity, how did you meet them? I mean, did you toddle off to Tokyo and knock on doors?
It was through our network, so I happen to know a few VCs out there. I was in Tokyo in December. finalize the deal.
Excellent. Congratulations. So that sounds absolutely great. But as you say, you're halfway there. When would you hope to close the round and have the money in the bank?
Yeah, we're looking to close out the round within the next couple of months.
Okay, we'll keep fingers crossed for
Essentially.
that. And when you do, let us know, and we'll give you a little blast on the BritChips podcast. But you mentioned ChipStart because, as you know, I'm talking to a lot of ChipStart founders. How did you get involved with them? How did you even hear about ChipStart?
I mean, it was on LinkedIn. That's how I initially found out about ChipStart. I saw a post about the first cohort, and I noticed there was an Imperial startup who was involved in the first cohort.
Right.
That's a Mint Neuro.
Oh, yeah.
So yeah, we went to talk to Dorian and Tim and get their impression of ChipStart. They loved it. Sounded like the first cohort maybe was a bit more chaotic than ours, but
Well, that was the first cohort, and yeah.
Of course, I mean,
and I know Dorian well. In fact, I did a podcast with Dorian a while ago. A terrific guy, great company.
Yeah, it's really lovely.
Yeah. So he talked you into it and said, "You got to give it a go, Alex. You got to give it a go," and you did.
Yeah, I mean, when it comes to accelerators, there's a lot of basically general accelerators. It's, general advice for startups, and it becomes noise to an extent when you're hearing different suggestions about how to start, how to get going when it comes to marketing, when it comes to investment and so on.
Yeah.
And oftentimes it's not really, it doesn't really correlate with your specific industry. And semiconductors is, I mean, it's super complicated, right? There's so many, it's very multifaceted. There's many different relationships at play. And it's also, it's this really, really large, really complicated industry, which you can't just go at it with a generalist point of view. So you need to understand the dynamics. You need to understand the relationships at play. And I feel like ChipStart, it really helped us with the specifics of the semiconductor industry. So, I mean, one aspect is with IP. You can give general advice around how you should patent your technology and so on, but what does that actually mean for any particular industry? That's one aspect. That's one example. When it comes to go to market, I mean, go to market is extremely tricky. It's extremely hard to work out where is the best entry point to, and also within semiconductors as well, because there's so many different levels to it.
Yeah.
So, understanding where your entry point should be.
ChipStart appoint a mentor, don't they, for each of their cohorts? So you've still got your mentor?
Yeah, I mean, I'd say the mentors are the most valuable aspect of ChipStart. I mean, it's pretty hard to find people that experienced and that well connected in the industry. It feels like all of the mentors have some relation to ARM, which I think is a massive benefit.
Yeah.
That's one of the biggest semiconductor companies in the world.
Yeah. I mean, do you want to give a name drop? Who is your mentor?
Oh yeah, so I mentor Steve Evans, a brilliant guy. He's such an amazing guy. He's he's really useful. I mean, consider the fact that the co-founders, myself and Petros, we're coming from research. Our experience is almost purely academic, and so figuring out the commercial strategy, that does require experience. That requires someone who's gone out and sold products similar to ours.
Been there, done that, and fallen for all the traps. And absolutely.
Exactly.
Yeah.
And Steve fits that bill to the T.
And he's still involved with you?
He's still involved, yeah. So he's joined the company as a part-time advisor.
Excellent. Well, let's talk a little bit about the future then to close out the story. You've got some customers, you've got this great partnership with Altera, you've got hopefully some money coming down the line. If you were to look forward, I don't know, 3 years, even 5 years, where would you like Heronic to be? What do you think it should look like then?
Yeah, so, well, within the next year and a half, we want to keep building this commercial traction. I mean, our journey at the moment, it starts with FPGAs, but it's definitely not going to end with FPGAs. So we see these devices as our go-to-market, our way to develop commercial traction and also gain insights into how people are using AI semiconductors. I think that's a massive benefit for us as well, is we get to see people, end customers, using our technology every day, which is kind of unique to some of the other, product related ASIC startups where they have to wait a few years for their chip to actually be manufactured, and then a few more to start gaining commercial traction. Yeah, we see this go to market as our way of getting a foothold in the industry.
Yeah.
And then we're looking to grow into ASIC IP as the next market for us. So
Well, that would be quite a different
going from-
market, wouldn't it? Because if I understand correctly, with ASICs, they say it is a silicon thing. So all the design work has to be done, and then eventually it goes and the silicon is produced. So you'd be involved at that beginning design process, because once the chip is made, there's nothing you can do, is there?
Yeah, so I mean, the way that we're designing, the output of our technology is this behavioral RTL. So it's a description of how to implement an architecture. It's not completely tied to the specific device, the specific technology. And so we can, from where we're at the moment, start targeting ASIC devices next.
When would you think that might happen?
I mean, we've had a few discussions already, but we're aiming to get that process started within the next couple of years for sure.
Well, that would be great. Well, we look forward to seeing how that goes. It sounds like, it's a really exciting journey, and as I said, you're only a few years into it, and yet you seem to have achieved so much, you and Petros. I mean, how many are in the team now? Is it just the three of you now?
It's just the three of us currently, but once we get this fundraising, then we're going to grow the team to it's going to be about 6 of us at that point, so double.
Well, that would be great. And clearly you'll be more funding required further down the line, but it's sort of a recursive process. You've got to get the runs on the board to prove the business case, if you like, and then you'll find more and more people hopefully happy to invest in you.
Yeah, of course.
That'd be the way to do
That's
it.
the goal.
Well, that's great. Well, look, thank you so much for joining me on the BritChips podcast, Alex. So Alex Montgomerie-Corcoran, co-founder and CEO of Heronic Technologies. Thank you very much, and all the very best for the future.
Thank you so much for having me.
It's a pleasure.
Cheers.